Okay, it's recording now. So, on D, you want to know what's the maximum possible area of a rectangle that has a perimeter of 80. So, X and Y are the lengths, and you want to maximize area. Now, the area is just the length times the width. But the thing is that it's a double variable function, and that's not fun. You can't really find the maximum of that unless you knew some other math called multivariable calculus. Perimeter is something called a constraint. You know that the perimeter, which is basically the sum of all the sides, is equal to 80. And here, like if I were to divide by 2, I'd have a condition that the sum of x and y must be 40. And what I can do is I could substitute this constraint as 40 minus x. If I substitute that constraint into here, then that makes this area function strictly a function of x. It would be x times 40 minus x, or basically a 40x minus x squared. Now, when you're trying to maximize something, you're trying to find its maximum, these are parabolas. This guy right here is a parabola that opens up like this. You're trying to find the vertex, basically. So how do you find the x-coordinate of the vertex? You always do negative b over 2a. It's the negative of 40 over 2 times negative 1. That gives you a value of 20. So 20 is the value of x that needs to be. If x is 20, well, you can go back to your constraint. Y is 40 minus x. Oh, it's also 20. What a surprise. The way to maximize a rectangle is if you make it a square. So all the sides are 20, and they want to know what is the largest possible area. That area is basically 20 times 20, which is 400. You could have basically said, hey, here's the vertex. X is my variable along my input, and then area is my output. So once you got X, you could have plugged it into this guy. So all these things, anytime you're trying to do maximization and minimization word problems, they basically all revolve around finding the vertex. Okay.
All right, so your first function would be the perimeter, and then the next one would be set equal to area.
Well, your area function is equal to x times y.
Yeah.
Your perimeter is a constraint, and it allows you to substitute one of the variables because you need your area function in terms of one variable, not two. So substituting that constraint, it's like a condition or like a restriction that you have to abide by into the function that you're trying to maximize. It allows you to find this expression, which is a quadratic. And that quadratic, you should just simply be able to do the, find the vertex. On all
And
of them,
so
you'll pretty
if
much
they
know this.
gave you the they gave you the area, you basically set up the area as your constraint.
Yeah, they
Okay.
wouldn't do that in this type of problem.
Uh-huh.
Well, I mean, they
Yeah,
could.
because then it's not a quadratic.
Well, no, not
Or
really. They could set up something like that, but then you'd have a function that has like the reciprocal of some variables. You might have to transform it into a quadratic by multiplying through, but it's possible you might have something like that. If you're given a
okay.
certain area, you might need to minimize perimeter. So,
All right.
okay. So E, you're told a clothing store sells 40 pairs of jeans at $30 each. So you know that 40 pairs are basically $30 each. And pretty much this is probably going to be like a supply and demand kind of situation. The owner figures that if you increase $3 in price, you're not going to sell as many jeans. You're going to sell 2 fewer pairs. So what price should be charged to maximize profit? Actually, it shouldn't be profit. It should be revenue. But whatever. In economics, your revenue is basically the price times the quantity. Okay. Right now, you are getting a revenue of $30 per pair of pants times 40 pants. You're getting $1,200 of Skrilla coming in. And the person knows that if he jacks up the price $3, then he's going to sell 2 less jeans. So if you now increase the price to $33, your jeans would be 38 sold, whatever that number is. If you jacked it up again and said, fuck it, $36, then you're only going to sell 36, and so on and so forth. The higher that you charge, the lesser people will buy. Simple supply and demand, all that other fun stuff. So they want to know how much money can they make, like what price is going to be set. So your revenue function should only depend on X. Let's just say that X is the number of pairs of pants that you want to discount, okay? Or number, X can be like the amount that you're going to discount, how many times you're going to discount. Your price is normally $30, but you could decrease the price by $3. Increase the price by $3 in multiples. You could be 33 or 36 or 39 and so on and so forth. How would your quantity change? Normally you sell 40 pairs of pants, but for every X amount, X amount multiple of $3 that you go up, you're going to lose 2 pairs of pants. And so 2x would represent the amount of pairs of pants that you would lose. So this was your base price and your base amount. This is the price increase, and this is the associated quantity decrease. This here is your revenue function. Ignoring the dollar signs, you could actually FOIL this out. Your revenue as a function of X would just be doing FOIL. 30 and 40 is 1,200. That's our original revenue right here. You'd have a 120 and a minus 60, so that's a plus 60x, and then you'd have this guy, which is a minus 6x squared. And what does this look like? A quadratic. A quadratic with a negative, like an open down bias. This is what your revenue would look like. You want to find out that sweet spot, what X has to be to make sure that you have maximum revenue coming in.
So then you just find the vertex?
Yep. X coordinate of the vertex is negative b over 2a. So it's negative 60 over 2 times negative 6. That becomes, I think, a 5. So if that's the case, then what would your maximum revenue be? Your revenue would be at a unit of 5. That would be 30 plus 3 times 5, 15. So you're charging $45 a pair, and you're selling 40 minus 2 times 5, you're only selling 30 pairs of pants. And whatever that quantity comes out to be, that would be your solution. So 45 times 30.
Okay. So the first half of your quadratic equation is it's like your price portion,
Yeah,
so it's $30
plus 3x.
And then the 3x would be your increase in price.
Yeah. Because X is that multiple of how many times we're going to increase the price.
Okay.
And then your quantity is
so the next portion would be the pairs. So it's going to be okay, that makes sense.
The 40 pairs of the 40 pairs of pants. But then also minus the 2x.
Okay.
Okay. So F you already did. G is Lorenzo making this feet of fencing to make a rectangular dog pen. So he already has his house. Here's his meth house. And then he's got to have a dog pen that, makes sure to feed the fucking deplorables to
chemicals.
These dogs. Yeah, like, shit, we have extra chemical. Let's feed them to the dogs. So here's the pen. If the house is already uses one side, he only needs 2 sides here and another side here. And we want to find the length and the width for the maximum area. So we want to find out what X is and Y is so we can maximize area. So if we're trying to maximize area, what is the area of the pen? Well, it's just the length times the width. But notice that we have 2 variables. This function depends on 2 variables. We do not want that. There has to be a constraint. he only has 48 feet of fencing. It's not like he has unlimited fencing. Otherwise, he'd just fucking build a pen as big as the world and say, fuck you, I'm going to go ahead and use this for my dogs. But no, that's not the case. Home Depot said, nope, got 48 feet of fencing, bro. So if you look at the fencing, it's these two sides and this side. We know that
So
there
would it be
is a constraint.
so would it be 48 equals 2x plus y?
Exactly. The 2x plus y dimensions must be 48. Let's go ahead and solve for y. It's 48 minus 2x, and substitute that into the area. That way, our area function is only a function of x. It's x times 48 minus 2x, or basically negative 2x squared plus 48x. What's the name of the game? We do the same old crap. Find the x-coordinate of the vertex. The x-coordinate of the vertex is negative b over 2a. And when you solve that, that becomes a 12. So we know that the dimension for x has to be a 12. How do we find y? We can go back to any equation that is associated with it. Right here, we know that y is 48 minus 2x. And if we solve for that, that's 24. Those are the dimensions that should give us maximum area. If we do a 12 by 24 for a pen, our area would be 288 feet squared, or whatever units they are. Yeah, I think it's feet. Anything else would not work. If x was 10, if I put 10 here and 10 here and 28, that would be 280. Ooh, pretty close, but not, 8 more square feet missing. I don't know. That's not too much, but whatever.
Extra room for the chemicals.
Yeah, exactly. Or like a little eating area, or a place for dogs to shit, Yeah. Not that they would just crap all over the place anyways. So,
yeah.
So that's the idea for the rectangular pen. Again, our drawing, we're trying to maximize area, so we write the area equation, and we notice that it's in two variables. But then we look into our problem, we notice, oh, we have a constraint, we have a restriction. We only have the 48 feet of fencing. So we have that. Cool?
Mm-hmm.
The very last one, H and then I. Find two numbers adding to 20 such that the sum of their squares is as small as possible. So, two numbers. Let's write them. Two numbers, let's just say that it's x and y. So we know that their sum is equal to 20. So we just say x plus y is equal to 20. This is a condition, basically a constraint, a restriction that any two numbers that you pick, there's some sort of rule. And then they say that their sum of their squares is a minimum. So if we wrote that sum of their squares, x squared and y squared would be some sort of function. It would be a sum function. And notice that it depends on two variables. Well, we don't want that. That kind of looks shitty. So what we do is we take our constraint, maybe solve for one of them. I like to solve for y and just pop it in for x. We'll solve for y and then drop it into this expression. What happens here is this sum function strictly becomes a function of x because you've wiped out the value of y. This becomes x squared plus 20 minus x quantity squared. And you could work through that. You could FOIL that shit out. Becomes x squared plus a 400 minus a 40x plus an x squared. And you can combine some terms. This is a 2x squared minus a 40x plus 400. This function here has an upwards opening, so that's why it's a minimum. What's the name of the game? Find the vertex. Find the x-coordinate of the vertex, negative b over 2a. So it's the negative of negative 40 over 2 times 2. That becomes 40 over 4, which becomes a 10. So if you know one number is 10, well, how do we find the other number? Use the constraint. Y is 20 minus 10, which is also 10. Cool. 10 and 10. Those are our numbers. They are the same. Let's test that out. If 10 and 10 are our numbers, we know that 10 plus 10 is 20. Check. What if we squared them both? 10 squared and 10 squared. That would be 100 plus 100. That would be 200. Cool. Let's try something else, like 9 and 11. we know that 9 plus 11 is 20. Derp a derp, like that's like, first grade math. And then square them. 9 squared and 11 squared. That's 81 and 121. If we added those together, what will we get? And it's not 200, we would actually get 202. So 202 is actually more than 200. Anything we try, 8 and 12, 7 and 13, 6 and 14, those would all make larger sums of their squares. So we pretty much got the two numbers right here. What would complicate this problem is if they said two distinct numbers, so where x and y couldn't be the same. But that would be kind of hard. I don't think they would do that to you. It'd be kind of a weird thing to do.
Mm-hmm.
Of course, if I was your teacher, I'd probably do it, and then you'd be guys like, would be like, oh, what the fuck, man? Game over, man. Game over.
I hate Rob.
Yeah. All right. On I, what is the largest possible area for a right triangle in which the sum of the lengths of the two shorter sides is 100 inches? All right. So we have a right triangle. Here's our right triangle. And we know that it's right. They want to know the largest possible area. Well, the area of a triangle is usually 1/2 the base times the height, right? So I'm going to write the base as x and the height as y. So here's 1/2 x times y. And we're trying to find the largest area. So we're trying to maximize this. The only thing is it's based in two variables, x and y. We need some sort of condition to, get this crap out of there. What are we told? We're told the sum of the lengths of the two shorter sides is 100. So we know that if we took x and y, we should get 100. And that is our constraint. If we take our constraint as 100 minus x and substitute that in here, our area function becomes a 1/2 x with 100 minus x. And if I distribute that, that becomes a 50x minus a 1/2 x squared. And guess what? It's a single variable function, and it has the look of a quadratic. It will open down, so the vertex would tell you that there's a maximum there. And of course, we're trying to find the largest area. What's the name of the game? Find the x-coordinate of the vertex. Negative b over 2a. Same old story. Once you get these equations in, it's pretty much automatic. So we take the negative of 50, divided by 2 times negative 1/2, and we basically get 50. So if our x value is 50, how do I find my y value? I go back to the constraint, and my y value is 100 minus 50, which is also 50. And boom, there we go. There's are the dimensions of the triangle. They want the area, so the area is just 1/2 x and y, 50 times 50. That becomes 2,500 over 2, or 1,250. And just to double check, if you wanted to do two other numbers, like 40 and 60, you could do that. 40 times 60 is 2,400 over 2, that's only 1,200. And you know that that's less than 1,250. And again, you could just keep checking them. You could do 49 and 51 on your calculator, but no matter what you plug in, you are not going to find anything that would yield a greater area. That's the whole concept of this stuff anyways. Cool?
Okay.
Down the road, you will notice something you'll see in your math classes called calculus, where when you have these quadratics, what's so special about the vertex is that the slope right here is 0. So there's a function there. Here's a function that opens with a vertex down here. Their slope is 0. There's something called the derivative. It helps you figure out where the slope is 0 just by performing a single operation. So it's a little easier than doing all this stuff. But that's another game. We'll learn that later on.
Okay. Do you know about the, our teacher calls it the sum and product of roots?
Oh, yeah. All right, okay. So a really quick way. So, like, what if I told you two roots, if root 1 was 5 and root 2 was -3, How would I find a quadratic? Well, I know that if those were the roots, then the corresponding factors would be x minus 5 and x plus 3. So then you could say, oh, my quadratic would be this multiple. This would be x squared minus 5x plus 3x minus 15. And if I, simplify this would be x squared minus 2x minus 15. Now, why the hell are they saying sum and product? Well, if I took the sum of these roots, 5 and negative 3, that would be a 2, right? If I took the product, 5 times negative 3, that would be a negative 15. In this equation, notice the negative 15 shows up. Notice the 2 shows up right here. It's an opposite sign, though. In general, when you have a quadratic in this form of x squared plus b over ax plus c over a, where there is no a in front of the x squared term, it's just assumed to be a 1. If you know the two roots, r1 and r2, if you take their sum, r1 plus r2, that always gives you the opposite sign of b over a. If you take their product, root 1 times root 2, that gives you c over a. That's just a really quick way of just figuring out the equation of a quadratic. So if your teacher said, hey, what if root 1 is negative 3 and root 2 is 7? If you added the roots, root 1 and root 2, that gives you a 4. So then you know it's an x squared minus 4x. If you took root 1 times root 2, that would give you a negative 21. So then you put a minus 21. It's always the opposite sign of the sum and the same sign of the difference, the product, and you'd have that.
Okay.
This is not really useful. I mean, it's not really like special if you did like easy roots, like, oh, look, 2 integers, whoop-de-doo. This is where it really comes in handy. What if your roots were really fucking retarded? Like, 1 plus root 3 and 1 minus root 3. Would this be fun? What if you took x minus 1 plus root 3 and then foiled it with x minus 1 minus root 3? Who the fuck would want to do that, right? That does not look fun. This would be a trinomial, x minus 1 minus root 3 and then x minus 1 plus root 3. Imagine doing distribution here, 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 and then here, 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 and then here, here, and here. That's 9 terms. You are prone to mistakes. Something is going to get fucked up, and that would not be good. We do not want that to happen. But what if we do this? What if we take root 1 and add it to root 2? If we took 1 plus root 3 and 1 minus root 3 and added them, oh, wow, that makes a nice 2. This number is negative b over a. So far, we could put x squared minus 2x. What if I took root 1 and multiplied by root 2? 1 plus root 3 and 1 minus root 3, they're conjugates. So their middle terms, the middle term of the FOIL, they all drop out. If you FOIL it out, it'd be 1 plus root 3 minus root 3. Those guys drop out. And then the last term, when you multiply those guys, it just becomes a minus 3. This becomes a negative 2. And that negative 2 is your product. So that would be your C over A term. Isn't that so much easier than trying to figure this out? I mean, this is not impossible. If you worked this out, you would have like x squared minus x plus root 3x, and then a minus x and a plus 1 and a minus root 3. And then you'd have a minus root 3x, a plus root 3, and a minus 3. And if you got everything right, you can kind of see like, oh, look, the negative and positive root 3 drop out. The negative root 3x and the positive root 3x drop out. And then these guys make a negative 2x. And then the 1 and the negative 3 make a negative 2. Not bad. It just, what if you mess up? What if you foiled off something wrong and it just became a trap.com? So that's where the sum and product of the roots really help out. Cool?
Mm-hmm. And also, here, hold on, I'll send it over to you right now, but it's basically finding a value using the sum and product of roots.
Okay.
So it's going to be J and K.
Okay. Okay. So find k such that the given number is a root of the equation. So for this one, when you have x squared plus kx minus 5 is 0, you know this number was if you took root 1 times root 2 to get a negative 5. And your goal is to write out the possibilities. Well, there's only two ways that you could do this. You could do negative 5 times 1 or 5 times negative 1. And you have to see which ones would make. It says find k such that the given number is a root. The condition here is that k has a positive in the front. I don't know if k has to exclusively be positive, but if root 1 was negative 5 and root 2 was 1, your sum, root 1 and root 2, would be a negative 4. So you know that you can have like basically the opposite right there. A 4 could actually work. If you did it this way, if you said root 1 was 5 and root 2 was negative 1, root 1 plus root 2 would be a positive 4. But then you have to swap switch the order. So there's two ways that you could have written this. You could have written it as x squared plus 4x minus 5, which I think is what they want because they're exclusively saying a plus is here. If they're accounting for all the possible values of k, they could have said that this would be x squared minus 4x minus 5, because there's two ways to factor this, as a plus 5 and a minus 1, or a minus 5 and a plus 1. The fact that they make that positive, I think that they want their k to be 4. I think they would have explicitly said x squared minus kx minus 5 is equal to 0. They would have specifically said there's a minus in front. On k, when you have x squared plus 6x minus k is equal to 0, here they say find k such that the given root. I didn't see the fact that they said 1 was a root. So, all right. Never mind. Sorry about that. J is actually much easier. They're saying that x squared plus kx minus 5 is 0, and they already tell you that one of the roots is 1. So just plug in 1. That's probably the easier thing to do. 1 squared plus k times 1 minus 5 is 0. Your k value comes out to be 5 minus 1, which is a 4.
Okay.
For k, again, plug in 3. If you have x squared plus 6x minus k is 0, and one of the roots is 3, just work with the fact that 3 squared plus 6 times 3 minus k is 0. So then, 9 plus 18 minus k is 0. Your k value is 27. That's pretty much it.
Okay. Let's see. So I'm going to send 2 more problems over.
Okay.
So it's going to be F and G.
Okay. So F, you have a system 2x squared minus y squared is 8, and x squared plus y squared is equal to 19. What this looks like, just to kind of give you an idea, this guy's a circle. Circle centered at the origin with a radius of whatever the root of 19 is. This guy has a particular shape. It's called a hyperbola. And a hyperbola with the x being positive would look like this. Now, you could have 3 situations. You could have that the hyperbola doesn't touch the circle and you have no solution. Or you could have the hyperbola just touches right here and here. Or you could have that the hyperbola actually comes in and strikes like so, and then you have 1, 2, 3, 4 solutions. Those are all the possibilities. We'll know which solution it is depending on if we get like an imaginary solution or not. What's the best way to do this? Elimination. If you have 2x squared minus the y squared is 8, and then an x squared plus the y squared is 19,
Can you just plug in the y squared or
well,
the x squared,
what if you
whichever you choose?
What if you added the equations? Then you get a 3x squared and nothing right here is a 27.
Yeah. Uh-huh.
Here, x squared would be 9. And if x squared would be 9, if you root both sides, x could be 3 or negative 3. If it's 3 or negative 3, now let's see what y would have to be. And it's your choice which one to plug in. I'm going to plug into the second one. If y squared is 19 minus x squared, then y squared would be basically 19 minus 9, which is a 10. And if you rooted both sides, y would be the root of 10, but it would be plus or minus. So that kind of tells you it's the 4 solution situation. If x is negative 3, y could be plus or minus 10. So here's negative 3. You could have negative root 10 or positive root 10 up here. If it was positive 3 over here, again, you could still have negative or positive root 10. So that's a 4 solution scenario. The way that you know it's 4 solutions is the fact that x gave you 2 solutions and y also gave you 2 solutions. So 2 times 2 kind of tells you that's 4 total.
Mm-hmm. And then so like if x gave you 2 solutions, but then y gave you like 1 solution for each individual x value,
the only one would be it. Yeah, the only solution could be is with 0. Like if x was 3 or negative 3, and then y was 0, then you have this guy right here in green. You have this part touching and this part touching, because those are the only ways that it would work.
Okay.
Okay. Is it G?
Yeah.
Okay, so G, we have this area. You have 1,800 feet of fencing, which is to build 3 adjacent rectangular corrals as shown. Okay, so 1,800 feet of fencing is your constraint, and you want to find the dimensions and maximum total area enclosed. So here, what I'm going to do is I'm going to label all the sides. I'm going to go ahead and label this as Y, 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 and Y. And I'm going to label this whole thing as X. So this whole thing is X, and this whole thing is X. Because when you look at the dimensions, really, it's the total length here, and then the total width here. So I know that 1,800 has to add up to all the lengths, the 4 Ys and the 2 X's. And if I divide everything by 2, just simplify it, I have that 900 is equal to 2y plus x. So that's one of my constraints. My area is what I'm trying to maximize, and my area is simply just the length times the width. And here I can go ahead and solve. I don't have to write it area as just as a function of x. I could write it as a function of y. If I solve for x here, it would be 900 minus 2y. So if I substituted that crap here, my area would only depend on one variable. It would be 900 minus 2y times y, or basically negative 2y squared plus a 900y. The name of the game is find the vertex. You could say the y coordinate of the vertex, because this is y comma a. This is your input, that's your output. This is still negative b over 2a. So it's still negative 900 over 2 times negative 2. Doing that gives you, 450 over 2, which is 225, I believe?
Yeah.
So that's your y value. How do you find your x? You just go back to your constraint. So x would be 900 minus 2 times 225. That gives you 450. So you know that 450 as a length, and 225 as a width. Those are your dimensions, and that would give you your total maximum area of whatever 450 times 225 is.
Okay.
You could have also, solved this if you feel only comfortable using x's. You could have said that y was 900 minus x over 2, or basically 450 minus 1/2 x, and then substituted it into the area function. You'll get the same exact thing. So it doesn't really matter.
All right. And then also, how would you graph imaginary numbers?
So imaginary numbers are not graphed on the xy plane. The xy plane are for real numbers. For imaginary, or basically complex have an a plus bi. This is the real term. This is the imaginary term. They're graphed on the real imaginary axis. So I'll give you an example. What if you were to graph 2i? That would be 0 plus 2i. So you'd go 0 over in the real and 2i in the imaginary. So that's 2i. What if you did 3 plus 4i? You'd go 3 over in the real and then up 4i and then draw a point. That would be 3 plus 4i. If you did -1, you would just go over -1 plus 0i. Or I'll do -4. You would go -4 units in the real and then up or down nothing. And that would just be -4 plus 0i. Okay? That's how you graph real and imaginary numbers. They're just single points.
Okay.
They're called complex numbers. A complex is a combination of a real part and an imaginary part.
Uh-huh. All right. I think that's it.
Okay. You have a test anytime soon? Or quizzes?
Apparently we have on Friday, so.
Okay. Anything on chemistry? Or has chemistry just kind of been chill lately?
Chemistry's just been balancing equations. Like, yeah, chemistry's not too bad right now.
Okay. You guys are just balancing regular molecular equations, right? Nothing in redox?
Yeah, we just got into redox, but redox isn't too bad.
Okay.
Redox is just like, isn't it? You just you balance based on like the atoms, and then you balance based on charges.
Yeah, you'll make half reactions, and then you balance them depending on if they're an acidic or basic solution. More often than not, everything's an acidic, and yeah, you balance. You balance the atoms, then you balance the charge by adding electrons to one side to balance charge. So you never add protons because it's only electrons that can be added, because it's only the electrons that are being transferred throughout the reaction. So yeah, nothing that bad and fairly simple. But teacher could put hard ones on there, something that we can review for next week.
Yeah. Let's see, we do have a test on that stuff in chemistry on Thursday, though. So
Thursday, okay. So
yeah. Let me open up my notes really quick so we can see if there's anything I need to go over. Is there anything specific I would need to know about like combustion reactions?
No, actually, I mean, combustion reactions is either an organic compound, CXHYOZ, or just a hydrocarbon, CXHY. You're always adding oxygen, and you're always going to get CO2 and H2O. That's okay. Yeah, that's combustion. And it's always going to be complete combustion. They're not going to fuck with you and say, oh, you also produce carbon monoxide or some other bullshit. No, it's complete combustion. So.
I mean, I guess why don't we go over redox reactions?
So for redox, again, like there's a half reaction that takes place. So let's just say that you have Al3 plus and zinc, and then that goes to zinc 2 plus aluminum. The half reactions are quite easy here, especially on element reactions. The zinc and the zinc 2 plus is going to be the reaction here. So if zinc goes to zinc 2 plus, the only way that you could balance this is by putting 2 electrons. This is the oxidation reaction because the 2 electrons are being stripped away. They're on the product side. The aluminum, here you just have the Al3 plus going to aluminum. The way to balance this is 3 electrons here. So here's your reduction side. You have to balance the amount of, electrons. So you multiply this guy by 3, this guy by 2, and so then you know overall, if you were to combine all these guys, you'd have 3 zinc, 2 aluminum 3 plus, and 6 electrons on the reactant side, and then you'd have 3 zinc 2 plus, 2 aluminums as a solid if you wanted to put solid other states, and then 6 electrons here. The electrons are supposed to drop out to the end, and this is the overall reaction.
Okay.
It's really not that bad. If you had a half reaction like this, I'll just go over it. This is something called a skeletal reaction. Here you're looking at like, what the fuck do I do here? And if you're told that it's an acid, this is what you generally start off by doing first. First, anything that is not oxygen or hydrogen, you make sure that it's balanced. The nitrogens, cool, they're balanced, check. The next thing that you do is in acidic solution, in order to balance oxygen, you need to add water to the side that needs oxygen. This side has 3, this side only has 1, so you need 2. You need 2 oxygens, so what you do is you add 2 waters. Because what you have just done is you just added those 2 oxygens. But what did you just do? You added 4 hydrogens. For every water that you add to one side, you add twice the amount of H+. That's the counterbalancing that you have to do. So you need 4 H+ on this side, okay?
Mm-hmm.
That balances all the elements. Now you have to balance charge. What is the charge on this side? 0. What is the charge on this side? 4 plus and a 1 minus becomes a 3 plus. The side with the larger positive charge, or like the less negative charge, that's the side that needs the electrons. You can't add electrons to the right, you have to add the electrons to the left, and you need to neutralize it to 0. So if we added 3 electrons to the side, that would be producing that to 0. This is the half reaction for that guy in acidic solution. For basic solution, it becomes really easy. You take this expression, the 3 electrons, the 4H+, the NO3 minus, going to NO and 2 waters. And for every H+, you add a hydroxide. If you add 4 hydroxides here, and if you add 4 hydroxides here, this now becomes water. So 4 waters and nitric acid, or nitrate, going to NO with 2 waters and 4 hydroxides. There's 2 waters here that get knocked out with 2 waters here. So you kind of rebalance the waters just by knocking out whatever's excess on one side. And that would be your basic reaction. Okay?
Mm-hmm.
So those are the rules. If you have to do something basic, do it acidic first and then make it basic. Just so much easier.
Okay.
Cool. All right. If your chemistry test is next Thursday, let's meet Monday and let's go. You just have a good amount of chemistry that we can go on over.
Oh no, it's this Thursday.
Oh, this Thursday.
Yeah.
Oh, okay.
Uh-huh.
Oh, never mind. If for some reason you wanted to meet again on Wednesday and go over tons of stuff, let me know and I can see if I can squeeze in some time.
Okay.
Okay.